All right, in this video, we're going to look at how firms price products that are intangible. An intangible good can be thought of as a good that has really no theoretical limit, no theoretical capacity. An example would be, software downloads or streaming videos, right? And the idea there is that 1 million people are downloading a software title, or 1 million people are downloading a Netflix video. Does it cost more to the company if 1,000,001 is downloaded? That cost of that 1,000,001 unit being downloaded probably costs the same to the company as the 1,000,000th download. So downloads of video or downloads of software titles are intangible, and the marginal cost of that additional download is close to zero. So we're going to do that with this fictional company, Cyberdyne Systems. It's a fictional company in the Terminator 1, 2, 3, 4 universe. And in the latest, or in the, I think it was in the latest iteration, Terminator Genesis, it developed this Genesis operating system. And we're going to assume that because the AI that is embedded in it, it's compact code, it's platform independence. Genesis made all of their operating systems obsolete, and everybody downloads, right? And there's no capacity limit to these downloads. And we'll assume that its total cost of operations is that number, right? The marginal cost of an additional download is zero. Again, that billionth download is no different than the 1,000,000,001, right? In terms of cost to the company. Thus, the firm's supply curve will be perfectly elastic at the price it ultimately sets. And it has asked you to estimate the demand for its product, which you have done. And your demand curve is right there at 300.6 minus 0.09 times quantity, right? Your demand curve is going to be different than mine, but the mechanics used in this problem are going to be all the same. Okay, so there's my demand curve. If you notice, there's a light gray curve in the background. And that light gray curve is the revenue equation. And what I've done is, you can see right here, the revenue graph is gray, and it's not to scale, right? What I've done is I've graphed it. To graph it with demand, I've had to divide each revenue value by 1,000. So the scale for the demand curve is the vertical axis. The scale here is the price. So notice that if no one has downloaded it, the first person is willing to pay for it is $300.60. So that's that point there on the demand curve. And then as the good becomes less and less scarce, the price that last person is willing to pay falls, right? So the price axis here, the y-axis here, are the prices along this demand curve, right? Now for the revenue equation is this thing in blue times quantity. That's the revenue equation. And the graph of that is this light gray curve. And in order to fit it on this graph, I divided, like I said, each value by 1,000. So if you want to think about what value of revenue this is, it looks like, because I've divided it by 1,000, that revenue is, halfway between 200,000 and 300,000. So the peak revenue in my model is probably about 350,000, right? So if I wanted to, I could put the scale of revenue over here, or I could just add a K for 1,000, right? So revenue is about 250 here, right? It's 0 here and it's 0 here, and it curves up and then down, right? Okay, so we're going to use, if you click on this decimals.com link, you're gonna get a worksheet over here like this, right? So the first thing we have to do is we have to make sure that our demand curve matches up, right? So I'm going to copy the numbers with a minus sign in between and paste it over here. Okay, so there's my demand curve. And the first unit, the first person in line for this operating system will pay about $300 for the software, right? That's how we interpret the intercept. Okay, and it's downward sloping, right? The 3,340th person to download it would be willing to pay $0 for it, right? So that's our demand curve. Now, in order to fill out this table down here, what I'm going to do is I'm going to change this little q here to a big Q. And when I change that little q to a big Q, I'm going to calculate prices along the demand curve. So if my price is $300.51, then we're talking about the first person's willingness to pay for that software. Okay. So I changed that little q to big Q, and then I can calculate prices along the demand curve. If I change that to 2, if I change that to 2, notice that the prices come down. If I change that to, I don't know, 1,000, prices come down even further. If I change this quantity to 0, not 0, 3,300, the price drops to 3.6, right? So the 33rd person in line to buy this product is willing to only pay $3.60. All right. So that's how I get values along the demand curve. Now I've set up the rest of the Desmos this way. This calculates the revenue, price times quantity. So if the quantity is 1 and the price is $300.51, then the revenue is $300.51 because it's 1 times that value. If I change this to 2, now price is $300.42 times 2, you get 684 cents. Now this down here is a point elasticity equation. This is a point, this is the price right here. This is the price on the demand curve, right? In this case, it's $300.42. Oh, and I got to change this to Q down here. Sorry. I got to change that to Q. Okay. So this is price, and this is quantity, and these come from a point on the demand curve, right? So we're Q equal to 2, right? We're Q equal to 2 somewhere in here. Q equal to 2. It's going to be pretty close to this point here, right? Where Q equal to, price is $300.42, the revenue is $600.84, and the elasticity is going to be massive, right? This right here is 1 over the slope. So I got to change this value here because I'm using this equation here, right? Demand is linear, so this 0.09 is the change in price over the change in quantity. And in elasticity, you want this to be the change in quantity over the change in price. So we have to invert the slope, right? So when you invert the slope, we get the change in quantity over the change in price, right? This right here is the change in price over the change in quantity. And 0.09 divided by 1 is 0.09. So again, this is the change in price or the change in quantity. That's the slope, right? Rise over run. And we have to invert it to get the change in quantity over the change in price. Okay. And we can only do that if the demand is linear. If the demand is nonlinear, we can't use this elasticity equation. Okay. The book will teach you that you want to use the midpoint of the price in the midpoint of the quantity. I prefer the point elasticity, the elasticity at a given point, right? Okay, so we're gonna use, and now we've got the elasticity set up, right? This is the slope, 1 over the slope of the linear demand curve, and this is the price quantity ratio, okay? And the last thing we gotta do to make sure it's set up right is we gotta get the cost. I'm gonna copy the cost from my problem setup and paste it right here. Okay, so this is my cost. It's fixed, right? All the investment has been put into place into this production process. All of it's in place, right? Everything's fixed. The production line's going, and all people are doing is downloading the software title, right? And this down here is my profit. The revenue, my economic profit, my revenue minus my cost. So that's my economic profit. All right. Now we can go down and fill out the table. Okay, so the first quantity in my case is 1,220. 1,220. Okay, at 1,220, my price is 190.8, $190.80. Right? So I'm gonna type that right here. Right. My elasticity to 2 decimal places is 1.74, right? The 7 in the third spot makes that a 4 when we round to 2 decimal places. And then my revenue is 232,776. And we'll hit enter to make sure we got it right. And everything looks good. All right. So we'll do one more and I'll let you do the rest of them on your own. Okay, now we got to change the quantity to 1370 here, right? 1370. Copy that. Now your quantity is gonna be different than mine. You got to get it from your table, right? When I plug 1370 into my demand curve, I get a price of 177.3. 0. I get an elasticity. Again, the third place value is 7. It's 5 or more. So I got to make that 1.44. Notice elasticity is coming down, right? The price has come down and elasticity has come down. And now the revenue is 242,000. 901. 242,901. Hit enter. And so we have all those things, right? So I'm going to put a pause in the video. Okay, I stopped the video to fill in the rows here. And if you're struggling with filling in the table, I'll do one more for you, right? So the last quantity in my table is 2,120. So I'm going to change this to 2,000. The Q, the big Q, 2,120. Make sure that this is a big Q here, right? And that gives you a price of 109.80. My elasticity has dropped all the way down to, this is a 5 here, so this 7 becomes an 8 when I round to 2 decimal places, 0.58. And my revenue is $232,776, $232,000, $232,776, right? And now I've completed my table, right? And notice my revenue peaks out at what I thought it would peak out at, right? It peaks out at just above 250,000. So this, the gray scale, the revenue scale, these are in 100,000, each of these heights of these boxes. So 100,000, 200,000, 300,000. And this is in the middle, very close to the middle, $250,001, right? Okay, so now, based on the analysis above, you recommend that Cyberdyne systems charge what dollars per download, right? Notice your revenue, right? Revenue rises and then peaks out and then declines, right? It's actually symmetric, right? These two values are the same. These two values are the same. And these two values are the same, right? With your height. So revenue is a parabola here, right? With a zero at zero at zero and a zero at close to 4,000. Okay, this crosses the x-axis about 4,000, right? So notice the elasticity is 1 here. When your elasticity is 1, if you price in such a way that your elasticity equals 1, then what you're doing is you're extracting as much from the customer as possible. You can't get any more out of them. And if your costs are fixed, that's how you maximize profits. And we'll see that in a second. Okay, so based on the analysis above, you recommend that CyberDyne system charges, I'm going to charge the price that makes this possible, the price that makes elasticity 1 and revenue maximized. My price is $150.30, right? At this price, the supply curve, let me go ahead and hit enter here. Hasn't drawn it in yet. But remember, we're picking the price, right? We're picking the price where our elasticity is 1, right? That's our price. So our supply curve is a horizontal line. The supply is perfectly elastic at this horizontal line of 151. Is a flat line, perfectly elastic at a price of 150.30. Now, when I hit enter, you're going to see the supply curve in our graph. Okay, so Math automatically inserts a horizontal line at the price we've set, right? At the price we've set. Okay, now, according to this diagram, supply and demand meet at a quantity of what downloads? Well, right here is our quantity, right? The price is what we set it at. The quantity is whatever this value is. And it's between 1,500 and 2,000. It's closer to 1,500. And where else is this quantity reported? Well, it's reported right here in the table. There's nothing to calculate here, right? When the quantity is 1,670, the price is 1,530 according to our demand curve, right? So if we set the price at this, we expect to sell 1,670 units, right? We expect to sell 1,670 downloads. And then what is our profit equal to? Well, let's make sure we got this right. Our profit's already calculated over here, right? Here's our quantity. Here's our revenue, right? Our revenue is 132,776. Whoop, sorry. We got to reset to 1670, right? Okay, so if we set the price at $150.30, we expect 1,670 downloads, right? If we get that and we have a price of 150.3, our revenue is $251,001, right? Now our costs are fixed because we've sunk all this programming, research, and then production. We've sunk it all, right? So our costs are fixed, right? When I take the revenue minus the cost, which is right here, we get a profit of 32,630. Whoop. There you go. Because the slope of the revenue at the price CyberDyne sets equals, let's go back up here, the slope of revenue. We're not talking about revenue, right? Right here, we're talking about the slope of revenue. Now, if I zoom this in, I wonder if I can zoom it in. Let me take a picture of it. I don't know if you can see it there. So here, at the peak, the slope here is 0, right? I'm not sure if you can see it. Right. Let me erase that. I don't know if you can see it. But you can see the gray here, right? At the peak, it's flat, right? At this peak, it's flat. So if you're on a flat surface and you step, if you're right here and you step a little bit to the left and you step a little bit to the right, you don't really go down much, do you? Right? So the slope at the peak of a curve is 0. The slope of revenue at the peak of revenue is 0. And the slope of revenue in economics, whenever we talk about slope of something, the slope of some curve, we're talking about the marginal, in this case, marginal revenue. So the marginal revenue is 0, right? Now at this price that Severn has set, right? At this price of $150.30, the slope right here at this peak is 0, right? So the marginal revenue is 0 at that point. And remember, the marginal cost was assumed to be what? And that's a reasonable assumption, right? The marginal cost is 0. Why? Because our costs don't go up. If at one moment we have 1 billion downloads, and the next second we get our 1,000,000,001 download, our costs don't really go up. So we have a marginal cost of 0, right? So at this point, the marginal revenue equals marginal cost, and the profit is maximized. I got to delete this word profit here. Hang on. Okay, I just went into the code and deleted this word here. I didn't need it because it's right here, right? So what I'm gonna do is I'm gonna go ahead and hit submit, and you're gonna see that word's disappeared. There we go. So real quick, the marginal cost is 0. At this price, the quantity is 1670. Revenue is maximized at $251,001. If I take a little step to the left, a little step to the right, revenue doesn't change much. Changes very, very tiny, right? So we can say the marginal revenue is 0, right? It's really close to 0. If that step is infinitesimally small in either direction, revenue is not going to go down. So marginal revenue is 0, marginal cost is 0, and so profits are maximized. Now this problem doesn't violate our profit maximization rule in economics, right? Where firms choose an output level such that marginal revenue equals marginal cost. If they do that, they maximize profits, right? Here we have marginal revenue and marginal cost both equal to 0, and our profits are maximized. Okay. All right. So that is lab 6.